All right, hi students. Okay, so you had a guided reading after you took your test on Tuesday. You had a guided reading for chapter 5, lesson 1. So just real quickly, I want to go through those notes with you just real quickly. I'll pause here and there, but mostly I'm going to speed through them because you were responsible for reading those. A lot of things are review and just with some new components. So we're going to focus on the new components after I give you the answers to the guided reading. So A1, a physical change does not produce new substances. Remember, those are changes in like appearance as far as color, shape, size. Okay. 2, during a chemical change, new substances form. The starting substances and the substances produced have different physical and chemical properties. It completely changes their identity. Whole new identity. And the reason that happens is bonds are broken. Like on this equation, the bond between the carbon and the hydrogen was broken and it was rearranged. So when that bond was broken, it was able to bond in with the O2, the oxygen, and now we have whole new products with whole different properties. Carbon dioxide is very different than methane. Okay? Water isn't anything like either one of those. All right? So when the bonds are broken, new bonds are formed, new identities of new substances are formed with whole new properties. All right. B, a chemical reaction is a process in which atoms of one or more substances rearrange to form one or more new substances. So that's what I just demonstrated for you. B1, sometimes changes in physical properties such as color or odor indicate a chemical reaction. 1A, formation of bubbles of a gas can also be a sign of a chemical reaction. Last semester I did vinegar and baking soda with a balloon on the top to try to show the law of conservation of mass. One of the byproducts was gas, and it was captured in the balloon. Okay, so gases can often be one of the byproducts of a chemical reaction. B, a solid formed when two liquids are mixed is a precipitate and can be evidence of a chemical reaction. 2, a change in energy. So if your temperature goes up or the temperature goes down, depending on whether it was endothermic or exothermic, we've learned those words, a change in energy would be a change usually in temperature, right? All right. A, thermal energy is absorbed or released during a chemical reaction and is evidenced by warming or cooling. Endo is absorbed, released is exothermic. B, light energy may also be released during a chemical reaction. Those are fun when you see light given off, photons. 3, the only way to be certain a chemical reaction has taken place is to compare the chemical properties of the substances before and after the change. C1, during a chemical reaction, atoms of elements or compounds rearrange and form new elements or compounds. 2, atoms rearrange when chemical bonds between atoms break. D1, a chemical equation, which is what I have here. A chemical equation is a description of a reaction using element symbols and chemical formulas. So we have our subscripts. We'll be talking about coefficients today as well. 2, element symbols represent elements, of course. A, symbols of elements are shown on the periodic table. B, when an element exists as a diatomic molecule, the element symbol is followed by the subscript 2. So this O2 is a diatomic, okay? Cl2 happens a lot, it's a diatomic. H2 happens a lot, it's a diatomic. All right. Number 3, chemical formulas represent compounds. That's a compound. Okay, 3A, a chemical formula contains element symbols and subscripts to describe the makeup of a compound. B, when chemical formulas differ, they represent different substances or different compounds. Number 4, a chemical equation includes the substances that react and the substances formed or produced. So we've got reactants on the left side, products on the right side. So the way you could read that to help you remember, reactants produce products. Reactants produce products. Okay. 4A, reactants are the starting substances in a chemical reaction, and B, products are the substances produced. C, in a chemical equation, the reactants are written to the left of the arrow and the products are written to the right. D, two or more reactants are separated by plus signs, as are any two or more products. So you see my plus sign, that is an equation. E1, the law of conservation of mass states that the total mass of the reactants before a chemical reaction is the same as the total mass of the products. You cannot create or destroy atoms from going from reactant to product. You cannot create or destroy them. You're just rearranging, and you have to count for everybody. So everybody, that we're going to be balancing equations. So everybody has to be accounted for. So nobody's lost, but nobody's gained. You can't mysteriously have oxygen on this side if there was no oxygen in the reactants. That's like you can't have chocolate chip cookies if you didn't put chocolate chips in the batter. They don't just magically appear when you put them in the oven. All right, same thing. All right. Number 2, mass is conserved in a chemical reaction because atoms are conserved. What that means is accounted for. 3, to show that mass is conserved, a chemical equation must show that the number of each type of atom must be balanced or the same on both sides of the equation. A, chemical equations are balanced by adding coefficients. And B, a coefficient is a number placed in front of an element symbol or chemical formula in an equation. So yesterday on the video I balanced this equation for you. Right off you can see that hydrogen is not balanced. Reactant side has 4, product side has only 2. So we put a 2 here. That gave me 4 hydrogen, but that also gave me 2 oxygen here and 2 oxygen here, which is a total of 4 oxygen, but over here I only have 2. So I put in a coefficient, because what times 2 is going to be 4? 2. 2 times 2 is 4. Over here I have 2 plus 2 is 4. So my oxygen are good. Carbon 1, carbon's good, and hydrogen 4, hydrogen 2 times 2 is 4, so that's all good. This is just like multiplying everything after it. It's just like multiplying anything that follows that, okay? Just like math. All right, so we're gonna do some practicing counting atoms. So, for example, iron oxide, Fe is iron. So I have iron, and there's a subscript 2. I know it might be hard to see on that. There's a subscript 2. So I have 2 iron, 2 atoms of iron, and I have a subscript 3 here following the O. So oxygen has 3. Okay? This is NaCl, those subscripts. So that means sodium 1, chlorine 1. This is a diatomic. It's Cl2. Almost forgot how to spell chlorine. Cl2. Okay. Here, I'm gonna write this larger so you can see it. rearranged. So, you know, when we were doing the periodic table puns and I said, I'll count it wrong if you don't write the symbol correctly, this is why. It's really important to have your symbols written correctly so that you know when it's another element. Whenever there's a capital letter, that's another element, okay? So Na is sodium, so there's no subscript, so there's one sodium. O is oxygen, no subscript, so there's one oxygen. And H is hydrogen, so there's no subscript, so there's one hydrogen. Okay? So that's how you count atoms. I wanted to look at a couple different pages. Page 154 is a reminder of when we talked about indicators that a chemical change has taken place. It's a reminder of that information from what we studied last semester, at the end of last semester. So formation of bubbles, change in color, change in odor, those are all indicators that maybe a chemical change or chemical reaction is taking place. So page 155, if you look at the bottom of that, you should look at the bottom of that and see what's going on. They're using little sticks to represent bonds. So make sure you look at that diagram and understand what's going on in that diagram. So initially, bonds are broken between the oxygen and the hydrogen in two water molecules. You'll see that there's an arrow and it shows them all, the bonds are all broken, there are no bonds. And then it shows another arrow, and what it did was it rearranged the hydrogen bonded to the hydrogen and the oxygen bonded to the oxygen. That's how, if you run an electric current through water molecules, you can actually break those bonds, and that's what would happen. You would end up with hydrogen and oxygen separating, and they'd be diatomics, H2 and O2. Okay. Page 156 is some more practicing of how to count atoms and how to count them if they're in parentheses. At the very bottom of page 156, magnesium hydroxide. Take a look at that one. Magnesium is on the outside of the brackets, so there is no coefficient on that, so, and there's no subscript, so there's only one magnesium. The hydroxide is in parentheses, and then there's a subscript 2. So that means there are two hydroxide atoms. Hydroxide travels as a bonded pair, OH. So there are two of those. So that means there would have to be two oxygen and two hydrogen in order to have two OH hydroxide molecules. Right? All right. I think in class we're also going to look at page 158 about how to balance chemical equations, and we're going to look at that conservation of mass down there at the bottom. So you need to look at that and see how they're accounting for every single atom from the reactant side to the product side, and they're showing you that after the reaction took place, they're showing you they still had the same mass. And then underneath it, they're showing you they had accounted for every single atom between the reactant side to the product side. Nobody was lost, nobody was gained, they were just rearranged. All right? Tonight's homework is going to be to draw the table on page 160. And what I mean by that is, if you look at that table, step number 1, because we're going to start balancing chemical equations tomorrow. We're working on how do you count. Now we're going to balance chemical equations tomorrow. Tomorrow's focus is going to be balancing those equations. So step number 1, you write the unbalanced equation. So that's what I want you to write. All the little extra words you don't have to write. Underneath that it says make sure that all chemical formulas are correct. You don't have to write that. Just write step 1, write the unbalanced equation. And then to the side of that, write your unbalanced equation that they give you. Okay? If you want to use color, I would match, and I would use color. Most of you should use color. A lot of people can actually recall it better if they used the color. I would match your color that you're using like they used blue for hydrogen and red for oxygen, I would do that, and I would also do it when I write the equation. I would write H2 in blue plus O2 in red yields H2 blue, O red, so that you actually start making those connections is what happened along the way. Then step 2, count atoms of each element in the reactants and in the products. So you'll write step 2, and then off to the side of that, just like it is in the table, I want you to make the circles and everything. I want you to make everything that's in the right-hand side. I want you to make all that. The words just need to be the bold-faced words at the top, because then if you do the other part, it actually shows you the rest of the step, what that step means, right? Thank you.